This is the solution set for the stats homework, page 60, numbers 1, 3, 7, 13, and 14. So with number 1, we're talking about the time it takes to finish the Iditarod. The first thing I'm going to be doing is going into my stat lists and entering in this data. So I just finished entering in all the data. You can see this reads 58, one back is 57, so it matches at least the number that are in the list. Hopefully I entered in every number correctly. Now I need to find what my intervals are going to be. There are going to be 5 classes. So I need to know the maximum and minimum. So I find the easiest thing to do is to go into stat. Let's sort this. Number 2, and then that's going to be very easy to look at. The minimum is 236, and then all you do is go up and go. The maximum looks like is 360. And then I think these are hours it takes to complete the Iditarod in hours. Yep. So now what we need to do is just do a difference divided by the number of classes, which in this case I think we'll ask for 5. So this is going to be 124 divided by 5. Which turns out to be 24.8, and you always go up. So we're going to use an interval of 25. So what we can do is create our frequency table. Do this. So we're going to start at our minimum, 236. And it's going to be all the x's equal to or greater than 236 but less than 261, because that's 25 more than 236. So we'll finish off writing this. Just to show you how I did this, I guess, quickly. What you can do easily is you go 236, hit enter, and then you can just go plus 25. And then you can keep hitting enter, and it'll just keep generating, the next one. And that's an easy way to generate all the intervals. So there are all my intervals. Now the first thing I'm going to want is to find the frequencies of those intervals. Now I can use my calculator to do that very quickly by creating a histogram in the calculator. To create the histogram, I'm going to use the stat plot, which is up here, so I'm going to go second y equals. Now we have 3 stat plots. I'm going to use the first one. So number 1, I'm going to make sure it's on. It is on. In type, you definitely want to select this histogram, and xlist will be our data. Frequency should be the number 1 if we're dealing with an original data list. If we have a frequency table and they're using that, then this won't be the number 1 anymore. Now what we are going to need is to adjust our window settings. Now we know that the x coordinates are going to be these numbers, so we need to go from 236, or if you, like I do, I like to go back 1 interval, gives a little space. If you subtract 25 from 236, you get 211. Now we go to x max. We want to go a little bit over 1 interval, over 361. And actually, I'll show you something that's kind of cool. You can enter 361 plus 25, so you don't even have to do it in your head, and it'll do it for you. X scale is particularly important. This needs to be the class width, the interval. All right, so this has to be 25. That's going to be pretty important. And then I do like a negative gives you a little space. I'm not quite sure how tall these are going to be. Let's just keep it at 20. And I'm going to check my y equals. Nothing's there, so that's nice. If anything was there, I would have cleared it out. Hit graph. And there's a histogram. Now it looks like we need to increase our y max. There we go. Maybe let's make that 30. Oh, and there we are. And you can see the y min being negative kind of bumped it up a little bit. That way, when I hit trace, you know, it's still blotting out a little bit. So I actually might want to maybe make this negative, just make it negative 10. And now when I hit the trace button, it doesn't really interfere with the reading of the graph. And in trace, all I have to do is hit the right arrow, and this n value tells me how many are in this interval. Notice how it's set up that min of this interval is equal to 236. So that matches with how I've written this as being x greater than or equal to, so that's part of this interval, but less than 261, so it matches up nicely, and this gives me my frequency. That's 4. Now I can move to the next one, and 9. And next one, and see, this makes it very easy to generate frequency table. Once we have all the frequencies, then what we are going to want are the relative frequencies. Now, if we were to add up all of these frequencies, this should equal 57, and you can check it. It does. Now, to calculate relative frequencies, I need to do 4 divided by 57, see what that equals. 9 divided by 57, see what that equals. You have to do all of these. Now again, there's an easy way to do this in the calculator. Go back into your stat lists. I'm going to go and enter in my frequencies. I'm probably going to need these anyways. Then I can go over to the next one, and I can enter a formula. Notice I'm up in the header of the stat list. I can say, well, all of L2, all the values of L2, I want to divide by 57. And what that's going to do is going to fill L3 with each element divided by 57, which are going to be all of my relative frequencies. So I can, this is 0.07, 0.16, 0.44, 0.28, and 0.05. Now if I add up these relative frequencies, it should, and it does, equal 1, because these are really probabilities. So if you add up all of them, you should get 100%. Now the next thing, and what I'm doing is I'm anticipating what we're being asked for. We're supposed to draw a histogram, which we're going to use the frequencies to draw the histogram. Part D is we're supposed to draw a frequency polygon, which is the frequency polygon. We're going to need the frequencies as well. Then E is the relative frequency histogram. That's when we need the relative frequencies. And F is we need to draw an ogive. And for that, we need the cumulative summation of our frequencies. So again, conveniently, this is something that we can do. I already have something in L4. I'm going to clear that. There's a very good function. I have to go up into the header. If you try to do it when you're in here, you'll get an error message. What you need to do is I can go to stat list, and in operations, ops number 6 is the cum sum function. I hit number 6, and notice that down here on the edit line I see cum sum, and what I'll do is I'll say please do a cumulative summation of L2, and that gives me all of my cumulative summations that I need for my ogive. Now it's just a matter of drawing these things. I'll do that on the next screen. So here's C, the histogram, and here is part D, which is the frequency polygon. A few details here. Notice that the points on the frequency polygon is midway through the interval. And that's about it for these. Here is, oops, not C anymore. This is E, and this is F. You can see I use the same axes. This would be the relative frequency histogram. And then this is the ogive, which shows you the cumulative summation. The benefit to this one is you can see where the growth happens most quickly. And there's those answers. Question number 3 talks about the percent of children in various neighborhoods of Denver. So here's number 3. I've already entered all the data into my L1. So what I can do is let's order it. And we can find, here's our minimum is 5, maximum is 53. Now in number 3 we're asked for 7 classes, so we would max minus min divided by 7, which is going to be 48 divided by 7, which is equal to 6.9, so we're going to use 7 as our class width. We can create our intervals now. We're going to start at our minimum 5 and go by 7s. Here's the rest of the table. Like before, I'm going to go and make a stat plot. This is all set up for the last one, so it should be good. Now the windows is going to be a little different. Right, our minimum, right? If we want, 5, but move back 1, minus 7. Right, and then 54 plus 7, just to give us a little space on top and bottom, or left and right. Of course, X scale is the interval. That's very important. That needs to be 7. Let's see what that looks like. All right. I could probably make my Y max a little smaller just to make it a nicer picture. We could maybe that would be 20. Maybe I could make this 6 instead. Well, that looks pretty good. And so we have, here's our first interval is 4, 7, 12, another 12, and it looks like the next one's also going to be 12. And then it goes down to 2 and 1. So what I'll do is I'll put that into my other ones. There's still a bunch of lists filled up. I'll show you a little trick. Number 4, if I hit my stat button, clear list, and I can tell it to clear L2, comma L3, comma L4. And it should have cleared all those lists at once. That's kind of convenient. So now we can enter in 4, 7, and again, we're going to need two different columns. We need relative frequencies, so this is going to be L2 divided by, and there are 50 numbers in L1. So that gives us our relative frequencies. And then, remember this one's going to be our cumulative summation of L2. And so we get all of our data. And there's the numbers transcribed into our table. And now on the next screen, I'll start making our graphs. Here are the graphs for C and D, the histogram, and the frequency polygon. And here is E, the relative frequency histogram, and part F, which is the ogive, showing the cumulative summation. Now we're moving on to question number 7, which is about the age of senators. Here you can see is part A, in which we're asked to find the midpoints of the class of the ages, and make a table. And here's the frequency polygon for the 95th Congress. Superimposed on top of this, I'll put the 103rd Congress. And there's the 103rd Congress. Now part C is to comment on the differences. Part C asks to do a comparison. And what I said was that in the ages above 60, which is this upper end of the graph, there doesn't seem to be much difference. But here in the lower part, there does. The 103rd Congress seems to have fewer younger aged senators, but more middle-aged senators. In the 95th, the opposite, fewer middle-aged with more in comparison to each other. Moving on to question number 13. This deals with 5 different versions of an anatomy physiology test and comparing the two, or comparing all 5. So this is how I'm going to structure my solution. It asks for comparing each of the version types, so I'm just going to do it in a table. That way I can keep it well organized. First thing it asks you to do in part A is to categorize the different distributions. And so you can see that the first one is skewed left, uniform, symmetric, bimodal, and then skewed right. With the first distribution, the skewed left one, seems like the majority do quite well on this test, which from a student perspective is an advantage. From a teacher perspective, it does raise the question that maybe it's not testing all that it should be testing. One of the questions that is asked in number 13 is which one would you want to take as a student? This would probably be my choice. I'd probably want to take this one. Here's the uniform distribution, which I can tell you as a teacher of 16 years, this doesn't usually happen. It's very unusual. But what it would indicate to me is that there is a wide range of performance still. When you complete a unit and you test on it, usually you hope that most people do pretty well, but with this kind of uniform distribution, there's still a wide range of performance, which indicates probably a fair number are still not getting it. Here is the symmetric distribution, which is consistent in its results. Most of the students are getting about the same grade. It's just a little unfortunate that that grade is kind of low. It's telling you that most of the students are still not not getting it in a systematic way, where different than the uniform distribution, which indicates different misunderstandings, perhaps. This seems to be a more systematic misunderstanding, a little different approach as a teacher to how to remedy those. The bimodal distribution means that there's a group that does pretty well, and then there's a group that isn't doing very well. It's a polarized class. The advantage is that you can actually identify a group needing help, and perhaps you can identify those who are doing well that can move on. So here's the skewed right, which means the majority are doing poorly, which means there needs to be an investigation about why. And, is the test actually an unfair test? Did the instruction not match what was being tested on? There's all kinds of reasons why a whole class might do poorly. But a skewed right definitely is an indicator that you have to look at that. And now we move on to the last question, number 14, where we're given information about the annual household incomes from product warranty cards from 5 different products. We're asked to do a very similar thing to the last question, categorize and compare and discuss. So here's the table I set up. Part A is just identifying the distribution type. Oops, I seem to have switched these things around. Hold on a sec. Oh, nope, actually I was looking at the wrong tables. So the first one is clearly uniform. We have B is skewed right. C, skewed left. Now this one might cause some discussion. Some people might look at that as bimodal, because that lower end at 25, is a bit of a peak. But remember, bimodal, it's really the top 2 intervals have to be separated. And here, the 55 and the 56 are the 2 top ones, and they're together. So this really wouldn't be bimodal, so it's skewed left. And then, of course, D is bimodal, so the 2 biggest frequencies are separated. And then, of course, E is symmetric. Of course, part B is if you're in charge of advertisement, what would be your approach given the information. For a uniform distribution with the microwaves, it seems to have broad appeal. Everyone is buying them, so I guess a broad-based advertisement would be appropriate. With the skewed right distribution, I would say that advertisement would need to target the wealthier people because they're not the ones buying it, electric fans. So if you increase the number of wealthier people buying, you'd be able to increase your sales. With the skewed left, with the computers, it's quite the opposite. You'd have to target the lower incomes so that you could increase sales from that segment. And of course, with the bimodal, you're going to have to target the middle because they're the ones not buying the big screen TVs. So you have to encourage those folks to spend their money on your product. And with the symmetric, of course, you have to target both ends. Both the high income and the low income don't seem to be interested in snowblowers, so you have to work on both ends. And for part C, it asks you to discuss and comment on whether you think the information is valid, which is always an incredibly important question for any work in statistics. And in this particular case, I actually questioned the validity of that data. I think with these little warranty cards, people don't feel particularly obligated to report their incomes accurately. They could put down anything, Today I feel like a millionaire, they put down whatever they feel like. So it really may not reflect actual spending habits from that particular income level.